kinetic interpretation of temperature. Prediction of temperature. So, what do we know? So, consider 1 mole of gas. 1 mole of gas. Here N stands for 1 mole. Okay. Density of the gas is rho, mass by volume. So we know pressure is equal to 1 by 3 rho. Please try to understand, this is mean. I'm not writing that bar once again. So then we can write P equals to 1 by 3 mass by volume into mean square. Or you can write this as pressure into volume equals to 1 by 3 mass into V square. So this is PV. Now 2 by 3 into 1 by 2 capital M, not small m. That is the total mass of the gas, V square. What is this? Isn't this the kinetic energy? So PV is equal to PV 2 by 3 of the energy. Again, we are doing it at which temperature? We are doing it at high temperature, low pressure. So from ideal gas equation, PV equals to nRT, but N we have taken as 1. So PV equals to R into T. Therefore 2 by 3 E is equal to R into T. So E would be equals to 3 by 2 RT. This is the expression for energy of the kinetic energy of the gases in terms of kinetic theory of gases. So this is kinetic energy of the molecules, mean kinetic energy, I'm forgetting that mean kinetic energy of 1 mole of gas, mean kinetic energy. We're going to use this in class 12 also. We're going to apply the same technique for electrons inside a conductor. So don't forget this. Therefore, again, so we know R we have got. So what is R actually? Let us go back. You see, I have derived this relation earlier. R is equal to Boltzmann's constant into Avogadro's number. So Kb is equal to Boltzmann constant is equal to R by Avogadro's number, right? Therefore, we can write E equal to, so average energy will be equal to total energy by number N, Avogadro's number Na, correct? So this is mean, remember. So now this is the total energy, this is total energy by total molecules, 1 mole, total molecules, right? Or Avogadro's number in STP, right? Therefore, E would be equal to Na into mean kinetic energy per 1 mole. Therefore, Na we can write this as E equal to, we can write this 3 by 2 kT, 3 by 2 RT, 3 by 2 R into T. What is R? And R is equal to Kb into Na. What did I do mistake here? 3 by 2 R by N, 3 by 2 mean is, what did I do mistake? Okay, sorry. So this would be, this one would be, no? So we can write this as 3 by 2 RT by NA. So that gives me 3 by 2 KB into T. So mean kinetic energy per molecule, now it's molecule, earlier it was mole, per molecule is directly proportional to the absolute temperature. T. That means proportional to the T. Okay, so this is one of the most important relation. Now again, we know we have derived this. E equals to how much we have derived? E, we have derived this half rho V mean square. Also half rho V mean square, or we can write this as rho mass by volume into V mean square. So V for 1 unit or 1 cc, so you can see this half m V square. This is capital M for total mass of the molecule. So if I equate this and this and this, if I equate it, I'll see that half m V square is equal to 3 by 2 kBT. So half get cancelled. I get here V mean square would be, I'm again writing back to that V mean square, would be equal to 3 RT by M, if I'm not mistaken. 3, okay, sorry, why am I writing directly? 3 kb by M, Boltzmann constant by M, wait a minute, wait, let us not take this way, it would be problematic. Wait just a minute. So let us not take this. We have just now proved it would be better to take 3 by RT energy, right? So this is the average mean energy, kinetic energy per 1 mole of gas. So we can take this here only. This is also 1 mole volume. So we will take this as 3 by 2 R into T. So 2 get cancelled. I'm left with R by M into T. So V mean square would be equals to 3 RT by M, but R by M, 3 RT by M, or V RMS, root mean square velocity. This velocity is called the root mean square velocity of the root mean square velocity. Velocity of the molecules. So V RMS will be root over 3 RT by M. So you can see from here Vrms is inversely proportional, is directly proportional to root T, root over T. So if temperature increases, the graph would be something like this. So if I'm not mistaken, you can check. You see the curve, yeah, it is not a straight line. I was doing straight line, yeah, sorry, that's why I was having doubt. So it's not a straight line actually. The curve will be increasing. Means, what does this mean? This means faster is the motion, of the molecules of the gas, higher will be their kinetic energy. Higher will be the kinetic energy, and hence higher will be the temperature. Higher will be the temperature of the gas. Got it? Also note, at T equals to 0, what do you think? Vrms is equals to 0. This is absolute 0. This is the definition of absolute 0. This is absolute 0. So where the molecules are not at all moving, where the molecules motion stop, we will call it as the absolute 0. This definition can be asked that what do you understand by absolute 0? So you have to say the root mean square velocity, when the RMS velocity of the molecules is 0, then we'll call the temperature at which the Vrms is equal to 0, that means motion of the particles, they are not at all moving, we will call it the absolute 0. Understand?
Yeah, sure.